Section 250.24 of the 2011 National Electrical Code, or NEC, requires that all electrical equipment and metal raceways be grounded to the grounding electrode system. This includes the main disconnect switch and the main distribution panel. Therefore, grounding conductors must be installed from both the main disconnect switch to the main distribution panel and from the main distribution panel to the grounding electrode system. It is not uncommon for utilities to require a main disconnect switch outside the building, even when there is a main circuit breaker inside the building. This is because the utility needs a way to disconnect power to the building in case of an emergency or for maintenance purposes. However, the utility requirement does not exempt the system from complying with the NEC. Based on the information provided, it appears that the proposed installation design does not comply with the 2011 NEC because grounding conductors are not installed between the main disconnect switch and the main distribution panel, and grounding conductors are not installed between the main distribution panel and the grounding electrode system. Firstly, discuss the concerns with the engineer and request that the design be modified to comply with the NEC. Secondly, install the required grounding conductors between the main disconnect switch, the main distribution panel, and the grounding electrode system. If the utility requirement for a main disconnect switch outside the building cannot be avoided, consider installing a fused disconnect switch instead of a circuit breaker. This will provide the utility with a means of disconnecting power while still allowing the building to be grounded properly. Grounding is essential for electrical safety. It provides a low impedance path for fault current to return to the source, which allows overcurrent protective devices like circuit breakers or fuses to quickly interrupt the circuit. This minimizes the risk of electrical shock and equipment damage. The grounding electrode system typically consists of a metal underground water pipe, a ground ring, rod electrodes, or plate electrodes. The grounding electrode conductor connects the grounding electrode system to the equipment grounding bus in the main distribution panel. From there, equipment grounding conductors are run with the circuit conductors to all electrical equipment, providing a path for fault current to flow back to the source. In the case of a main disconnect switch located outside the building, it's crucial to ensure that the switch enclosure and any associated metal raceways are properly bonded to the grounding electrode system. This can be achieved by running an equipment grounding conductor from the main distribution panel to the main disconnect switch. The size of the equipment grounding conductor must be determined in accordance with NEC Table 250.122, based on the size of the overcurrent protective device protecting the circuit. The purpose of bonding is to create a lower impedance path for fault current to flow back to the source. This helps to ensure that overcurrent protective devices will quickly interrupt the circuit in the event of a fault, minimizing the risk of electrical shock and equipment damage. The NEC specifies the requirements for bonding in Article 250. It covers various aspects of bonding, including the types of equipment that must be bonded, the methods for bonding, and the size of the bonding conductors. When dealing with large services, such as a 2500 amp service, it's essential to carefully consider the grounding and bonding requirements to ensure that the installation complies with the NEC and provides a safe and reliable electrical system. It's always a good idea to consult with a qualified electrical engineer or inspector to ensure that the installation meets all applicable requirements. The NEC provides detailed guidelines for grounding and bonding electrical systems, and it's crucial to follow these guidelines to ensure electrical safety. In addition to the general grounding requirements, there are specific rules for grounding separately derived systems such as generators and transformers. These rules are outlined in NEC Section 250.30. Separately derived systems must be grounded in accordance with the NEC, and the grounding electrode conductor must be sized in accordance with NEC Table 250.66. The location of the grounding electrode is also important. The grounding electrode should be located as close as practical to the separately derived system. This helps to minimize the impedance of the grounding path and ensure that fault current can quickly return to the source. When installing grounding electrodes, it's important to follow the manufacturer's instructions and ensure that the electrodes are properly installed. Rod electrodes must be driven into the ground to a depth of at least 8 feet, and plate electrodes must be buried below the permanent moisture level. The NEC also requires that the grounding electrode system be tested to ensure that it has a low impedance path to ground. The resistance to ground should not exceed 25 ohms. If the resistance to ground exceeds 25 ohms, additional grounding electrodes may be required. Grounding is a critical aspect of electrical safety, and it's essential to follow the NEC requirements to ensure that electrical systems are properly grounded. By following the NEC guidelines, electrical professionals can help to protect people and property from the hazards of electricity. In many situations, there may be a metallic water pipe available for use as a grounding electrode. The NEC allows the use of a metallic water pipe as a grounding electrode, but it also requires that the water pipe be supplemented by an additional grounding electrode, such as a ground rod or ground plate. This is to ensure that there is always a reliable grounding path, even if the water pipe is disconnected or becomes non-conductive. When using a metallic water pipe as a grounding electrode, it's important to bond the water pipe to the grounding electrode system at the point where the water pipe enters the building. This helps to ensure that the water pipe is properly grounded and that fault current can quickly return to the source in the event of a fault. In addition to the grounding electrode system, the NEC also requires that all metal enclosures and raceways be bonded together to form a continuous electrical path. This helps to ensure that there are no voltage differences between metal parts of the electrical system, which could create a shock hazard. Bonding can be accomplished by using bonding jumpers, bonding bushings, and other approved bonding methods. The size of the bonding conductors must be determined in accordance with NEC Table 250.102. When dealing with sensitive electronic equipment, it's important to provide a clean ground to minimize the risk of electrical noise and interference. A clean ground is a grounding system that is isolated from other electrical equipment and is dedicated to the sensitive electronic equipment. Clean grounds are often used in hospitals, laboratories, and other facilities where sensitive electronic equipment is used. The NEC provides guidelines for installing clean grounds in Article 250. Surge protection is another important aspect of electrical safety. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges caused by lightning strikes, utility switching, and other events. SPD are typically installed at the service entrance and at downstream panels to protect sensitive electronic equipment. The NEC requires that SPD be installed in accordance with Article 285. When selecting an SPD, it's important to choose a device that is rated for the voltage and current of the electrical system. The SPD should also be UL listed and labeled. Regular inspections and maintenance are essential to ensure that electrical systems are operating safely and reliably. Electrical systems should be inspected at least once a year by a qualified electrical inspector. The inspection should include a visual inspection of all electrical equipment, as well as testing of the grounding system, bonding system, and surge protection devices. Any deficiencies that are found during the inspection should be corrected promptly. Ground fault circuit interrupters, or GFCIs, are another important safety device that are used to protect people from electrical shock. GFCIs are designed to detect ground faults, which occur when electricity leaks from the electrical system to ground. When a ground fault is detected, the GFCI will quickly interrupt the circuit, preventing electrical shock. The NEC requires that GFCIs be installed in certain locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or FSIs, are another type of circuit breaker that is designed to protect against fires caused by electrical arcs. Electrical arcs can occur when there is a loose connection, damaged wire, or other electrical fault. FSIs are designed to detect these arcs and quickly interrupt the circuit, preventing a fire. The NEC requires that FSIs be installed in bedrooms and other areas of the home where electrical fires are more likely to occur. When working on electrical systems, it's important to always follow safe work practices. This includes wearing appropriate personal protective equipment such as gloves and safety glasses, and using insulated tools. It's also important to de-energize the circuit before working on it and to verify that the circuit is de-energized using a voltage tester. Lockout-tagout procedures should be followed to prevent the circuit from being accidentally re-energized while work is being performed. Electrical safety is everyone's responsibility. By following safe work practices and adhering to the NEC requirements, electrical professionals can help to protect people and property from the hazards of electricity. In addition to the NEC, there are other standards and regulations that may apply to electrical installations. These include state and local codes, as well as industry standards such as those published by the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. It's important to be familiar with all of the applicable standards and regulations before beginning any electrical work. Continuing education is essential for electrical professionals. The electrical industry is constantly evolving, with new technologies and regulations being introduced all the time. By participating in continuing education courses, electrical professionals can stay up to date on the latest developments and ensure that they are providing the best possible service to their customers. There are many different types of continuing education courses available, including online courses, classroom courses, and workshops. The NEC is updated every 3 years, so it's important to stay current with the latest edition. The NEC is a comprehensive document that covers all aspects of electrical installations, from grounding and bonding to wiring methods and overcurrent protection. The NEC is available for purchase from the NFPA and other organizations. In addition to the NEC, there are many other resources available to electrical professionals, including textbooks, reference manuals, and online forums. These resources can provide valuable information and support to help electrical professionals stay informed and up to date on the latest developments in the industry. When designing an electrical system, it's important to consider the load requirements of the building. This includes the lighting load, the receptacle load, and the appliance load. The load requirements will determine the size of the service entrance, the size of the feeders, and the size of the branch circuits. The NEC provides guidelines for calculating the load requirements of a building in Article 220. Voltage drop is another important consideration when designing an electrical system. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction and can even damage equipment. The NEC recommends that the voltage drop on branch circuits should not exceed 3% and that the voltage drop on feeders should not exceed 5%. Conduit fill is another important consideration when installing electrical wiring. Conduit fill refers to the amount of space that is occupied by conductors in a conduit. The NEC limits the amount of conduit fill to prevent overheating and damage to the conductors. The NEC provides tables for calculating conduit fill in Chapter 9. When installing electrical equipment, it's important to follow the manufacturer's instructions. The manufacturer's instructions will provide detailed information on how to install the equipment properly and safely. It's also important to use the correct tools and equipment for the job. Using the wrong tools or equipment can damage the electrical system and can even create a safety hazard. When working with electricity, it's important to always be aware of the potential hazards. Electricity can be dangerous if it is not handled properly. By following safe work practices and adhering to the NEC requirements, electrical professionals can help to protect themselves and others from the hazards of electricity. If you are not a qualified electrical professional, you should not attempt to perform any electrical work. Electrical work should only be performed by qualified individuals who have the necessary training and experience. If you have any questions about electrical safety, you should consult with a qualified electrical inspector. They can provide you with information and guidance on how to stay safe around electricity. Remember that electricity is a powerful force that should be treated with respect. By following safe work practices and adhering to the NEC requirements, you can help to ensure that electrical systems are installed and maintained safely and reliably. Always prioritize safety when working with electricity. Never take shortcuts or compromise on safety for the sake of convenience. Your life and the lives of others may depend on it. Continue to learn and grow as an electrical professional. The electrical industry is constantly evolving, so it's important to stay up to date in the latest developments. By expanding your knowledge and skills, you can become a more valuable asset to your customers and to the industry as a whole. Strive for excellence in all that you do. Take pride in your work and always aim to provide the highest quality service possible. By doing so, you can build a reputation for excellence and earn the trust of your customers. Be a leader in the electrical industry. Share your knowledge and experience with others and help to promote safety and professionalism. By working together, we can make the electrical industry a safer and more rewarding place for everyone.